Hello again, geometry students. This is where I left off from the other video, and I want to pick it up and complete this practice test for you, those of you who want to see it. I'm here on number 2, and here we've got uh, instructions to find the length of AB in this triangle ABC. You can see here segment BD is perpendicular to this segment called AC. It also bisects it, as evidenced by these two tick marks here. So segment BD, this right here should be somewhat different. Should be capital D. Kind of close there, but anyway, segment BD is what is called a perpendicular bisector of this segment AC. So the theorem says that any point on the perpendicular bisector, could be this point, or it could be this very point here, B, is equidistant from the endpoint. Endpoints are A and C of the segment that is bisected. Therefore, very quickly, you could do this. You could say AB is the same as AC. So that being true, you could then set 11x minus 5 like this, equal to 8x plus 7. This equation will allow us to find x, and once we find x, we can plug the x value in here and find the length of AB, which is what we're required to do. So let's go ahead and do this. We're going to add 5 to both sides. Add 5 here and here. So that gives us 11x. 5's are gone here. It's equal to 8x. 7 plus 5 would give us 12. Then we subtract 3x from both sides. That will leave us 11. Take away 3. Sorry, this should be an 8x. Subtract 8x from both sides. I'm sure some of you caught that. 11x take away 8x would be 3x on the left, equals 12 on the right. And finally, divide both sides by 3 and we get x equals 4. Now this 4 will plug into the expression for AB, and so therefore AB would be 8 times 4 plus 7, or 32 plus 7. That would give us 39 for the distance between point A and point B. Okay, now a little bit more on the perpendicular bisector, number 3 here. Instructions are as follows. Given that JP, which is this, EP, which is this segment, and SP, this segment, are perpendicular bisectors. That's what we're studying here, perpendicular bisectors of this triangle, the best triangle you could have, GOD. Find the following. I want us to find the distance from P to O and so on. But let me say a word of about perpendicular bisectors to review. A perpendicular bisector, again, it's perpendicular and it also bisects the segment. So we have that OJ and JD are the same. Here's another perpendicular bisector. It bisects segment GD, so that ED and GE are the same, and the 90-degree angle is here. And finally, the third perpendicular bisector, SP, is perpendicular to segment OG, and it bisects it. so that we're going to have SO and SE being the same, as evidenced by the tick marks here. Now, the perpendicular bisectors, they converge at this point P. I'm sure you can tell me what that point is called. The point is called the circumcenter, a special, very, very special point. In fact, if we had a compass and we use this as our center and this as the radius, PO as the radius, and we draw a circle carefully, here's what we'd find. The circle would pass through each of the three vertices of this triangle. Okay? Therefore, distance from P to D would be a radius of the circle. From P to O would be another radius. And the third radius would be from P to G. And you know that all radii of the circle would be equal. Therefore, we could do this. 2, 3, 4. I've got 4 right here. 1, 2, 3, 4. And finally, 1, 2, 3, 4, like this. So now let's answer these questions. Part A, PO, distance from P to O. From point P here to O, it's going to be the same as from P to D, and you see P to D is 15. So PO is 15, just like PD. How about PG? From P to G, that would also be 15. How about JD now? This is different. There's point J, and J here is a midpoint. It's a midpoint of segment OD. Therefore, it's going to be the same distance as point O is from J. So JO is 10, so JD will have to be 10 as well. GO, let's see what about GO. GO is the whole distance of this segment here from point G all the way to the other endpoint at O. So what would that be? Well, this is 9. S is the midpoint, so that would be 9. So we have 9 plus 9. That would be 18 for the distance from point G to point O. And finally, GD would be what? Well, here we have E is a midpoint. And this is 13. So this will have to be 13. GD then will be 13 plus 13, or 26. Alright. First you can see that. Next, we're going to take a look at placing a polygon in a coordinate plane. We did this, maybe a couple weeks ago before the retreat. So let's take a look again. Place a square having the side length 7 units in a coordinate plane. Place it conveniently and find the coordinates of each of its vertices. So it's a square, and the length is 7 units, could be 7 centimeters or 7 inches. So let's mark that off. 2, 3, 4, 5, 6, 7. And on our x-axis, 1, 2, 3, 4, 5, 6, 7. This will be one corner here. So we can draw our square to look like this. And it says we should find the coordinates of each of its vertices. Alright, so let's give it a very nice name. Let's call this square LOVE. Okay, so let's go ahead and find the vertices. The coordinates of vertex V would be, we got 7 this way, comma 0. Of vertex O coordinates there. 7 this way and 7 that way, so it's going to be 7, 7. Coordinates of vertex L, nothing in the x and 7 in the y. Finally, coordinates of the origin, that's pretty easy. It's going to be our 0, 0. That's a convenient way, not the only way, but a convenient way of placing a square in a coordinate plane. You could actually place it over here as well, and then you get some negative coordinates. Some people don't like negatives, so they'd much prefer to have it over here. Alright, what else do we have here? Well, conveniently place a right isosceles triangle in a coordinate plane and write down the coordinate of each vertex. The length of the legs is 5 units. Running over here, but this is a right isosceles triangle. Here's a good way of doing it. We know each leg is 5 units long, so 1, 2, 3, 4, 5. That could be one leg, and the other could be 1, 2, 3, 4, 5 up here. So let's draw the legs. Let's brighten them up. This is one. Here's another one along the x-axis, and the hypotenuse would come like this. And here comes the right angle right there. So we have a leg here and a leg here, 5 units long. And you can notice the special triangle. It's a right triangle, as I mentioned to you, a righteous triangle, because it's not right. It doesn't have legs to stand on, right? So it does have 2 legs, and we can call it triangle. Let's call it R, G, T. Coordinates of T, I'm sure you can tell even before I write it. It's going to be 5 this way, comma 0, 0 in the Y, no movement in the Y. Coordinates of point R would be nothing in the X but 1, 2, 3, 4, 5 in the Y, so it would be 0, comma 5. And finally, coordinates of the origin, as usual, is our 0, 0. Okay, so that would be the extent of the review. I trust this will be helpful to you. And may God bless you as you prepare yourselves and do your best. Bye-bye.